everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week we're sharing insights from outages at Starlink and Google Maps SDKs. We'll also provide an update on the Red Sea cable damage and cover the latest global outage figures. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. On September the 15th, SpaceX's Starlink satellite internet service experienced a brief outage. What did we see there, Mike?
The outage itself lasted around 15 minutes. We saw it impacted users in sort of multiple regions, so North America, Europe, Asia, Australia, and this happened simultaneously. But not all regions were affected. The outage actually occurred during the overnight hours in North America, and it was actually late morning for Asia and parts of Europe there as well, which might have actually reduced the noticeable disruption. Starlink itself sort of relies on this network of satellites and ground stations and user terminals. Now, what we actually saw in this system was the issue itself impacted the ability to sort of resolve names. So we saw from some of the terminals in our test environment, the DNS resolution failed, which kind of indicated that we were making connections to Starlink's network, but we couldn't actually pass through it because effectively the DNS is occurring at effectively layer 3, and then we established that connection, but we couldn't pass data, which sort of comes into some coordinated issue was actually occurring across the Starlink environment in terms of sort of how the traffic was routed and passed through the Starlink network. So we could get onto Starlink network, we couldn't pass off to go to anywhere else. It kind of happened, like I said, it was around 15 minutes type of disruption that we actually observed from our tests. And it was a staggered recovery that we saw as it came across the various regions, which indicated this reconvergence of as the path sort of came back up. There was no distinct pattern. We saw some terminals have connectivity and then others until we got full restoration.
Given Starlink is often used in places where there's a lack of other connectivity, it must be harder to make contingency plans for service outages. What do you recommend here?
It does and it doesn't. I know that's kind of a consultant answer there, but in terms of we think about the Starlink network, it really is an ISP network that we come from there. Yes, it has different characteristics itself, but if I'm actually looking from a contingency, it's not essentially that I'm going to have two LEO providers. I'm going to have two Starlinks. I might have some other backup connection. Now, that might be from a 5G connectivity, or it might be if I'm actually able to get sort of fiber or those types of things in there. I've also then got to consider if I am completely rural, and then I might have some other sort of system to get in there. I might then have servers in place. But it really comes down to sort of understanding my environment, my characteristics, and sort of matching those two together. There is organizations who are using Starlink essentially for their prime service. And that's, as I said, those ones which have no other options. And then their mitigation plans might be something different. It may be they might not resort to a dial-up connection, but it might be that they have services that we can run autonomously for a period of time by having those types of connectivity. But otherwise, it really comes down to the simple one, is we plan for divergency effectively within our providers and how we actually get access to the various networks.
On the 11th of September, Google Maps users in some regions had trouble loading maps or accessing directions. Tell us more about that, Mike.
So the outage lasted just over 4 hours, and that was up to the point where full restoration was actually declared. Now, what made this incident distinctive was its selective nature. Users are accessing Google Maps through web browsers, experienced no issues whatsoever. It was the mobile apps that were integrated effectively to Google Maps SDK displayed. Now, we actually looked at the system itself. We could see network connectivity coming into the environment. So going into sort of the search and the Google Maps APIs and those types of things was all maintained. There was no problem whatsoever. So it's something very specific to that environment. So it manifested itself on Android and iOS platforms, but I said it was embedded within the SDK. The reason I mention that is because this was effectively an issue with that integration with the SDK itself. So that interaction with the SDK, how it made its calls, as opposed to a problem with Google Maps itself. And what would happen is once the app was loaded, it sort of failed to load the initial map. Attempts to sort of load the map tiles, which is what they use to sort of maintain the sessions, would also fail. And on occasions, then users actually sort of restart the application themselves. The difference lies here in how we can sort of understand it was within the SDK itself, is that these map tiles are sort of requests and processed individually. So web browsers make a direct HTTP request to Google's tile servers and then handle the render themselves. Whereas a mobile SDK utilizes more of a complex system where the Google software is embedded in the mobile app itself, and that does the tile retrieval and the rendering process. So this is then sort of how the SDK is effectively acting as intermediary layer. And this is where that breakage appeared to happen.
Just like the Starlink outage, this disruption appears to be software related or connected to a configuration change, which has been something of a theme this year. How can ITOps teams guard against configuration related outages and mitigate their impacts when they do happen?
It's all again all about understanding the service in context. So understanding that holistic service, what makes it up, what comes from there. We can't always understand the impact of different configurations that occur because we have effectively these modules, these different components, and we're utilizing different network media and these types of things. They can all interact and behave differently. So really what you've got to understand is it's less of an issue of sort of preventing these. Obviously you want to get to that stage, but it's when they occur, understanding where it is, where that fault domain is, the ability to sort of roll back if possible or implement some sort of mitigation in the first place. So I said, these issues will continue. As we start to sort of get better with the AI stuff, we can start to understand at scale. But you're never really going to be able to understand specifically the interaction, because you're always going to get these situations of a perfect storm. There's nothing to say this configuration or whatever was done in this place was the actual cause of the problem. Everything might have been working in that silo. It was only when it's put in that specific condition and environment it changed, which is why it then becomes important to understand my service holistically.
Now let's get an update on the recent damage to the subsea cables in the Red Sea. And it looks like we've seen some performance improvement, even though the cables are still being repaired.
So just as a recap, on September the 6th, there was disruption that affected several submarine cable systems. The damage appeared to occur near Jeddah and Saudi Arabia. And from what we understand, it was likely due to a commercial vehicle, a cargo ship, actually dragging our anchor through these cable systems themselves. Now, as we've talked about in the past, the ability to actually repair these systems, I have to actually go out and put a ship aground there. And the experts sort of estimate the repairs could take anything between weeks to months, depending on the ship's availability, regional permits, and those types of things. Now, what we suddenly saw on September the 14th was we're looking at some of these transit paths as they came through there, and actually saw the latency effectively return to that pre-damage level. So I'm looking at specific tests coming between there. It's passing effectively from Mumbai to Frankfurt. And I actually saw that latency, say, return to these pre-damage levels themselves. We know that the repairs haven't started. I actually did a search to see if the vessels have been launched to understand what was going on there, and they haven't actually been repaired. So that means that they've actually achieved these optimizations without the physical repairs. So they've effectively sort of found different routing strategies. They might have actually gone on alternative cable systems. They've routed the traffic to different areas. And in fact, in some points, as we're coming out of Europe specifically, I've seen some of the path changes where we've actually taken that. So therefore, we could pick up a different system. The time frame itself, if we're looking at sort of that 8-day recovery time, so from the time we had on September the 6th to that September the 14th, it highlights this ability effectively to sort of make the changes. So we made this immediate change where we kept that resilience up. We sort of shifted to where we were, but that time period then has allowed them effectively to either negotiate to get onto other systems, to make capacity in their back end by switching other stuff out. Remember, we've got to do this on a global basis. So sort of switching these things out there. But that time frame is relatively short. That sort of shows us this ability, this spare capacity, as it were, that we have within this subsea cable system and the routes that we can take. So even though there's part of that damaged system we can no longer go through, which actually in some cases means we have to go around the world, it doesn't necessarily mean that they then can't start switching capacity around, moving stuff off from a time-sensitive perspective, or readjusting how these things are delivered to effectively return that to a pre-normal state until they get to that situation where they're able to repair it and then they can restore parity.
It's easy to think of those subsea cables as one giant system where you can simply choose another route if one cable breaks, but of course the cables are owned by different companies. So I guess some of that 8-day process might have included negotiating deals to shift traffic onto different routes than it would travel normally.
Yeah, exactly. I mean, all the cable systems, they're not running full tack. There is spare capacity on them, either through a different frequency or band within the optics themselves, or stuff they actually leave sort of a headroom on there. And absolutely, you have to go through this negotiation to allow it. And it might not necessarily be with the cable operator. It might just be with another peer. right? So we know that provider B is actually coming on a different system. So we're going to change our peering in Mumbai or wherever it is so that we now pick up this other provider. So all straight away, we're using the same path, but we're coming on a different cable system that is undamaged. So it's understanding those relationships and changing that peering relationship that we have, which obviously there is some contract negotiation that has to take place.
Hardware-related issues can often take longer to fix than software problems. How can companies assess and refine their mitigation strategies during longer hardware-related outages?
First thing is we need to understand how long is this going to be for. So we identified there was this issue with the subsea systems themselves. So you know that period of time that's going to take place. So therefore, then you can start to enable the process where we're going to renegotiate with a peering partner, or we might be at that point where we're actually deploying a different service, or we have another POP where we can actually start to route traffic around. So it's really understanding the magnitude and the fault domain to start with. That's the first thing. And that comes across to any environment. If we talk about where we have maybe a fire at a colo or a data center itself, we understand it's going to take a long time to repair. So therefore, you know what you're dealing with and what you want to take. So going back to an example where NASA had this issue with one of their control centers, they actually worked out that it was a power failure. They knew it was going to come back in with that time. They didn't necessarily need to be in communication for that period. So the best thing for them to do was to wait. And then we have other situations where a data center's gone down. So we wait, and at some point you make a decision, we need to sort of switch over to that area. Now, this also then comes into this concept of understanding the SLAs. So what do we have? It might be an SLA with your customers or your downstream providers themselves. So how is that going to be impacted itself? And this comes into everything from our planning perspective. So this is really starting to build up my disaster recovery and understanding what's going on there. And then importantly, you've got to assume that issues are going to occur. We're going to have these problems. So what you then need to be able to get in place is the redundancy systems themselves, but also they've got to be there so that they're always available. So if these situations occur, we had this with the Starlink, we talked about that outage. If I'm relying solely on that, do I make a decision that, okay, during that period it's going to go down, I can take the risk, I can be offline, or do I need to go through the process of putting another cable in place there? Now, if I have that system in place, what I've got to be able to do is to make sure that is available when I cut over to it. And this is going to involve some sort of always-on testing. The analogy I always use in these situations is the telephone system. When I pick it up, dial tone's got to be there. This is the same with our redundancy systems. They've got to be up and available. And when we consider some of the regulatory bodies looking after the financial environment, this is actually specified in there that your backup systems have to be up and available and in place. And then you've also got to understand at what point do we trigger this mitigation? It could be that we need to sort of roll it over quickly. I said it could be that we just wait to understand what's going on there. It could also understand we need to reassign staff. We don't want to get into this war room situation. Do we take staff off this particular job to do this mitigation, or do we actually leave that and then we can just rely on automated processes? So it's really sort of building into this whole disaster recovery planning. You have to have these considerations and understanding effectively what's going on from there.
Thanks for the deep dive into those outages, Mike. And now let's turn to the overall outage trends. What have you seen in recent weeks?
So from September the 8th to the 14th, there were 301 global outages, which is a 2% decrease from the previous week, which was 308. So during the week of September the 15th to 21st, the global outages remained essentially stable at 302, so showing minimal change from the previous week. This 2-week period maintained a global outage activity significantly above the late July baseline of 187, where we had this sustained level of disruption activities we typically see as we start to come out of the Northern Hemisphere summer.
And what about the US outages, Mike?
The US experienced a spike in outages to 184 from September the 8th to September the 14th, which is an 11% increase from the previous week's 166. The US outages fell to 161 during September the 15th to 21st, which is a 12% decrease. So the US accounted for 57% of all observed network outages over this 2-week period themselves. So it was the majority of all outages observed were US-centric.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode is published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions and feedback to insightreport@thousandeyes.com. Until next time, goodbye.